Good morning. Let us look into another aspect of Gibbs energy, which we should understand when it comes to chemical reactions, because so far we tried to talk about in general system, and we talked in terms of useful work obtained from the system, and we said that the criteria for spontaneity is that delta G should be equal to a negative value, then it is spontaneous. If it is zero, it is a condition of equilibrium or reversibility. Now, when it comes to chemical reactions, the criteria remains the same. That means a chemical reaction is spontaneous when the delta G for a reaction is a negative value. So when delta G for a chemical reaction is negative, then the process or the reaction is spontaneous. But how do you calculate the delta G for a chemical reaction is what we need to understand. Okay, so when it comes to chemical reactions, certain things you should know about, and in that very important thing that you should know is the term called standard free energy or standard Gibbs energy. Now, what is a standard Gibbs energy? Now, standard Gibbs energy is also denoted as delta G naught. Okay, so delta G naught is the standard Gibbs energy. Now, what is the standard Gibbs? This naught symbol implies standard. Okay, let's look at this particular definition. What we see here is the standard free energy of formation of a compound is defined as the free energy change. Okay, it's a free energy change accompanying formation of a compound from its constituent elements. The reactants and product are respectively in their standard state. Okay, so whatever temperature they are in, but the standard states imply that they are in their respective state. Standard state means if it's a solid, it should exist as a solid. If it's a liquid, it should exist as a liquid. Okay, and apart from that standard physical state, the pressure also we are approximating it to be 1 bar. So under such conditions, whatever change in Gibbs free energy we measure, that is equivalent to the standard free energy. So this is the definition for standard Gibbs energy for a compound. So when we talk about a formation of a compound from its constituent elements, whatever Gibbs energy that you obtained, provided the reactants and the products are in their respective standard state and at 1 bar pressure, we can say that whatever delta G value you obtain, that is corresponding to the standard free energy. Okay, we understood. Now, what do you mean by standard conditions? So whenever a reaction is done in such a way that the reactants and products are in their respective standard states and the pressure is 1 bar, then we say whatever delta G we obtain, that is corresponding to the standard state. Okay, now how to do that? Okay, so this is a formula that we use for in general for a reaction. So if you want to calculate the standard Gibbs energy change for a chemical reaction, what we do is we sum the Gibbs energy of formation of the products, then we subtract it with the sum of the standard Gibbs energy of formation of the reactants. Okay, and here one thing you should note is that here we also include the coefficients. That means we have in a reaction we have the coefficient, so that is included in this particular expression. Okay, so if you know the standard Gibbs energy of formation of each of the products, and if you know the standard Gibbs energy of formation of each of the reactants, if you use this formula, you should be able to get the standard Gibbs energy for a reaction. Okay, and and here one approximation which you should keep in mind is that if you see this particular statement here, for the purpose of evaluating the free energies of it is assumed that free energy of all elements in their standard state is equals to 0. That means if you talk about suppose the standard Gibbs energy of formation for hydrogen gas, that is H2. Now, H2 in the reaction is existing in its standard state, that is gas, and its elemental hydrogen. Therefore, this is assumed to be 0. Similarly, if you talk about a kind of Gibbs energy for a simple element like iron, Fe, then it is also equals to 0. Okay, so all the elements, elemental, if you're talking about only elements, okay, in their standard state, then the Gibbs energy of formation of those elements should be equals to 0. So this is the approximation you should keep in mind. So for elemental elements in their standard state, Gibbs energy of formation is 0. So now this you will understand better when we look into a particular numerical here. So if you see here, given that the values of delta G naught for CO and CH3OH, CO means carbon monoxide, CH3OH means methanol, is respectively minus 137 and minus 166.2 kilojoule per mole, respectively. Determine whether the reaction is feasible or not. So we have, this is the given chemical reaction. If we are able to calculate delta G naught for this particular reaction, and if that particular delta G naught value, that means if we have to find what that this reaction is feasible or not. So that means if delta G naught for this reaction is negative, then we know that it is feasible. Feasible is another term used for spontaneity. Okay. And if suppose delta G comes out to be a positive value, we know that it is a non-spontaneous process. Oh, okay, so let us try to write the given facts first. So if you look at the given facts, we are given the delta G naught for CO, that is delta G naught formation for the CO to be minus 137.3 kilojoule per mole. Similarly, you are given delta G naught for the methanol liquid as minus 166.2 kilojoule per mole. Okay, now you are to calculate the delta G. You have to calculate whether you have to find out whether it's feasible or not. To understand feasibility, you have to find out the sign of delta G naught. So basically, you have to calculate delta G naught. So if they basically you have to calculate the delta G naught is what you have to calculate here. Okay, so delta G naught for a reaction is simply delta G naught is equal to summation G naught for product. Here you have to keep in mind, you have to multiply with the stoichiometry. Okay, so the product minus the react. So delta G naught product means here we have only one product. So it is G naught methanol, stoichiometry is 0, so it's fine, minus sum of the reactants. So reactants we have delta G naught CO, okay, and then it is 2 times delta G naught hydrogen. Okay, that is what you see here. Now, this particular part you know, this is given to be methanol. So it is minus 166.2 minus G naught CO is given to be minus 137.3 plus. Now this is H2 gas. Now this is elemental hydrogen. Okay, elemental hydrogen present in its original standard state, because hydrogen we know is an element and it exists in the gaseous form, and therefore we just now said that whenever you have the formation of an element, it should be equals to 0. So that's why this particular term will equate to 0. Now, when you solve this, it becomes minus 28.9. So this is the value of the delta G naught for this particular reaction. Okay, so since the value is negative value, therefore we can say that this reaction is feasible. This reaction is feasible, or in other words, you can also call it as spontaneous. So this reaction is spontaneous, or is this reaction is feasible. So this is how you should be able to calculate the delta G naught for a reaction. Now, sometimes you are not given the delta G naught of the form of the compound of the various reactants and products. But in that case, you can use this particular formula, which we already know by definition. Delta G is equal to delta H minus T delta S. But here, since we are talking about standard state, that's why we include these standard notations. Now let us look into a numerical connected with this also, and then wind up this video. So what do you see here is we are given a reaction. This is the reaction whose delta H naught is given and delta S naught is given. Temperature is given, and you have to calculate delta G naught NH3. Okay. Now this reaction is basically the formation of NH3 from its constituent elements H2 and N2 and H2. Now delta H naught is given, delta S naught is given, temperature is given to be 25. So here we have also been given temperature, which is 25 degree centigrade, or is equals to 298 Kelvin. We simply have to add with 273. Okay, so we are asked to calculate delta G naught NH3. Okay, delta G naught NH3. Okay, so if we use these terms, okay, delta H naught and delta S naught, these are for this particular reaction. Okay, this reaction, the delta H naught and delta S naught is given. So you can calculate delta G naught for this particular reaction. Delta G naught for this particular reaction you can calculate. You have to simply use this formula, delta H naught minus T delta S, substituting the respective values where you convert the kilojoule into joules by multiplying by 1000, and then you write the temperature as 298 Kelvin, delta S is 0.918 kilojoule, again multiplied by 1000, so it becomes joule per Kelvin. So when you solve it out, it comes out to be minus 33.19 kilojoule. Now, if you, as I told you before, this is the reaction of formation of ammonia from its constituent elements nitrogen and H2. We are asked to calculate the standard Gibbs energy of formation of ammonia. So when you talk about this, it actually means you are, if you want to calculate the delta G naught for this particular reaction, that is, if you simply divide this equation by 2, it becomes into, sorry, I'll write it again, all becomes 0. So basically, into half plus 3 by 2 H2 equals NH3. Okay, this is a gas, this is again gas, and this is again gas. Okay, so what you see is this reactions delta G is what you mean by delta G naught NH3. Okay, so right now what you have calculated, the delta G naught is for this particular reaction. That means it is for 2 moles of NH3. Okay, so this reaction means it is talking about 1 mole of NH3. So you simply have to divide this by 2. So it's for 2 mole. So 1 mole, what is the delta G naught? And that is equal to your actual delta G naught value. So you simply divide it by 2 and you get this particular value. Okay, so this is how you can use this expression also to calculate the standard Gibbs energy. So thank you. Have a nice day.